Hi, hello students. In this video, we're going to talk about writing a slope-intercept form of an equation. Specifically, write the slope-intercept form of an equation of a line that is parallel. Okay, so for the ones that are parallel, and I'm going to extend this to the ones that are also perpendicular. Okay. And what do they give us? They give us that y equals 3x minus 3, and the point that we're using is 2, 2. Okay. Well, the two things that you're going to need is the slope, your x1 and your y1. So this one, we're going to get the slope from here, x plus b. This line has a slope of 3, and since we want the line to be parallel, they're going to have the same slope. Okay, so that means the new line is also going to have a slope of 3. It has to go through this point, so this is your x1 and your y1. x1 is 2, y1 is 2. Okay, then you're going to start with your point slope formula. And that's y minus y1 slope x minus x1. Y'all ready? Here we go. y1 is a 2. This is y minus 2 equals the slope. This is m. The slope equals 3. X minus x1. x1 is also a 2. Yep. So the only things that you're going to substitute in are the slope, the x1, and the y1. Right? The y remains a y and the x remains an x. And now it's just, so now you just have to rearrange to slope-intercept form. So that means we have to leave the y alone on the left, and we have to move the term with x on the right and all the constants on the right. Here we go. Y minus 2 equals 3x minus 2. Well, we're going to have to distribute that 3. 3 times x, 3 times negative 2. And we have to move term with x, constant, but then we also have a constant here, so plus 2 plus 2. So now we have y equals 3x minus 4. This is the equation of the line that is parallel to that original line. My bad, off screen. All right, so how does this differ from perpendicular? Oh, and not much, so you're just going to have to bear with me. Let me write some stuff down. All right, so for perpendicular, we're still using this equation, and we're still going through the same point, but now instead of wanting a line that is parallel, we want a line that's perpendicular. And for perpendicular, your slope is going to be a negative reciprocal. Okay. For parallel is the same slope. For perpendicular is a negative reciprocal. So since the slope here is 3, right, this one right here, negative reciprocal, so this is 3 over 1, is going to be 1 over 3, and since it's positive, it's going to become negative. So this is the slope of the perpendicular line. This means perpendicular. And it's still going to go through 2, and it's still going to go through the y1, which is 2. Oh, I forgot the 1 here. There we go. Okay. So once again, you're going to start with what? Your point slope formula, which is y minus y1 equals m x minus x1. So y1 is a positive 2, so it's minus 2. The slope is negative 1 over 3. X, and this is a positive x1, so it's minus 2. And so now we're going to distribute the negative 1/3 into the x and the negative 2 by multiplying it in. So that's negative 1 over 3x. Negative 1/3 times positive 2 times negative 2 becomes a positive 2. Sorry, my brain was ahead of me. 2 over 3. No, sorry. 4 over 3. Right, negative 1/3 is, wow. Am I really going to have to edit this? I guess I am. Okay, 1, 2, 3. Okay, so when we distribute the negative 1/3 into the negative 2, that becomes plus 2 over 3. Okay, and term with the x, constant, but there's another constant here, so we need to move it to the other side. And please don't freak out over the integer and the 2 over 3. I mean, get yourself a good calculator that you can do fractions with, okay? But I don't have a calculator in my hand, so I'm going to do the calculation on the side. So it's 8 over 3. Okay? This is the line, the equation of the line that is perpendicular to the original one.